Hello everyone, welcome to my channel Civil Quick Revision. Today I am going to discuss with you the previous year question on earthquake engineering. So let's come to the first question. Which instrument measure earthquake waves? You can see the options are given, that is seismograph, barometer, hydrometer, anemometer. Here the correct option is seismograph. With the help of seismograph we can measure earthquake waves. Okay, come to second question. The point inside the earth where an earthquake originate is called what? Epicenter, hypocenter, focus, seismometer. Here answer is focus. As I have already discussed with you in my crash course earthquake engineering, the theory portion, you please go through that video, and after that you come to this revision. Okay, you understand clearly after seeing that video. Okay, now coming to question number 3. The magnitude of an earthquake is measured on what? Mercalli scale, Richter scale, Kelvin scale, Celsius scale. Okay, here the option is Richter scale. Okay, we can measure the magnitude of an earthquake. Okay, now if the question is asked the intensity of an earthquake, how we can measure? We can measure it by MMI scale or MSK scale. Okay, then their answer will be different. Now coming to question number 4, which wave travel fastest during an earthquake? Surface wave, S wave, P wave, L wave. Here the correct option is P wave. Okay, P waves travel fastest during the earthquake. Now coming to question number 5, the severity of shaking at a location during an earthquake is called what? It's intensity, magnitude, acceleration, or displacement. Okay, as I have already discussed in my theory video, you can go through that. After that you attempt these questions. The severity of shaking at a location during that is called intensity. Okay, now coming to question number 6, IS 1893 deals with what? Wind load, earthquake resistance design, fire design, dead load combination. As we have discussed it, that is earthquake resistance design. Now coming to question number 7. In India, the highest seismic zone is what? Zone 2, Zone 3, Zone 4, Zone 5. As you have all know that Zone 5 is the highest seismic zone. Our northeast region is also in the northeast Zone 5. Okay. Now coming to question number 8, the phenomena of sudden loss of strength in saturated soil during earthquake is called what? You see, question number 1, settlement, liquefaction, creep, percolation. The here answer is liquefaction. Okay, there is a sudden loss of strength in saturated soil. ঠিক আছে, তাৰপিছত question number 9 এটা হওক, what is the typical value of a peak ground acceleration for zone 5 in India? Okay, peak ground acceleration, as I have already discussed in my previous video. Okay, you go through that, you go and revise the notes. After that you come and join. Now you see here answer will be 0.63. It is the peak ground acceleration for zone 5. Zone 2, zone 3 and zone 5 have other zone 2, zone 3, zone 4 have other peak ground acceleration value. Okay, now question number 10, which factor reduces the seismic forces demand on structure? Ductility, rigidity, dead load, or live load? Okay, here you see ductility reduces the seismic force demand on a structure. Okay, now coming to question number 11, the response reduction factor, that is R, for ordinary RC reinforced moment resisting frame is how much? You see, 3, 5, 7, or 8. Here you can give the answer as a 5. Okay, you can got the value from the table I have already shown in my previous video. Now coming to 12, base isolation in building help in what? Base isolation help increases seismic force, reducing seismic force, increasing building stiffness, or it can increases mass. Here answer will be reducing seismic forces. Okay, that's why base isolation will given in the building. Now coming to which IS code provide guideline the ductile detailing? Question number 13, option is IS 456, IS 13920, IS 875, or IS 800. Here option will be the B will be the correct answer. IS 13920 is the ductile detailing code. Now 14, soft story is a story. Okay, here option will be the with a large stiffness, with a lateral stiffness, or with a heavy load, with a small mass. Here answer will be the with a lesser stiffness. Okay. Now question number 15, which of the following is not an earthquake resistant feature? You see, sorry, okay, here which of the following is not an earthquake resistant feature? Is a symmetrical layout, soft story, shear wall, or it's a base frame? Here soft story is not an earthquake resistance feature. Okay, as you have already discussed the theory, you just go through it, then you have understand properly to do this question. Now earthquakes are caused mainly by what? Tectonic plate movement, volcanic eruption, collapse of underground cavities, or all of the above. Here answer D is the correct one. All of the above will occur earthquake. Now coming to 17, a structure resonate when it will resonate. It's option here you see, forcing frequency is equal to natural frequency, damping is very high, mass is very low, your stiffness is very high. Here option A will be the correct answer. Force frequency is equal to natural frequency. You just remember this, okay, for now. Now question number 18, you see P waves can travel to what? Solid only, liquid only, solid and liquid, or gases only? Here solid and gases, both are correct. Okay. Now question number 19, time period of a building is inversely proportional to what? Mass, stiffness, dampness, damping, or base shear? Here answer will be stiffness. Stiffness is inversely proportional to time period. Okay. Now coming to 20, which area of India is least vulnerable to earthquake? It's Gujarat, Rajasthan, Kerala, Karnataka. Here you will remember this is Karnataka. Okay. Now 21, a sudden slip on a fault causes what? Volcano, earthquake, tsunami, or flood? Here you see answer is earthquake. Okay. Now question number 22, liquefaction is most likely in what? Loose saturated sand, dense dry sand, clay soil, hard rocks? Here option is loose saturated sand. In loose saturated sand, liquefaction is most likely to occur. Okay. Now question number 23, magnitude of an earthquake is related to what? Energy release, ground shaking, frequency, or fall length? Here option 23 is the energy release, and magnitude of earthquake is related to energy release. Okay, as I've already discussed the theory. Okay, you got directly from the theory, and then directly you correct the answer here. Which is not a primary seismic wave? You see, P wave, S wave, log wave, or none of the above? Okay, here C is not a primary seismic wave. Now question number 25. In response spectrum method, the maximum response is plotted against acceleration, frequency, time period, or mass. In response spectrum method, the maximum response is plotted against time period. Okay. Now coming to question number 26, P wave stands for what? It's a primary pressure wave, primary wave, push wave, particle wave. It's a primary wave. Now coming to 27, the parameter used to account for ductility in seismic design is what? Importance factor, response reduction factor, seismic coefficient, zonal factor. Here question number option is B, response reduction factor, account for ductility in seismic design. Now question number 28, base isolation devices are installed in the foundation, at roof, on the walls, at the center of mass. Definitely in the foundation. Now question number 29, highest earthquake intensity recorded on Mercalli's scale is how much? You see, it is 10, or it is 12, 8, 9. Here answer will be the this is 12. Okay. Now ductile structures are what? Brittle, flexible, heavy, or weak? As you all know that this is flexible, definitely. Now 31, you see, which of the following is the least important for seismic safety? It's a lightweight construction, symmetry in plan, weak beam, strong beam concept, heavy mass concentration at top. It's the least important for design. The option is heavy mass concentration at top. It is least important. Now coming to 32, which country developed base isolation technique? You see, Japan. Japan is a developed country where they use base isolation technique. Now coming to 33, the damping ratio of a typical RC beam is about what? 2%, 5%, 10%, or 15%. As I've already discussed in my previous video, you see the topic, this is 5%. Okay, now which of the following loads does not vary during an earthquake? Dead load, live load, wind load, seismic load. Here answer is dead load. Dead load will not vary during an earthquake. Now question number 35, dynamic analysis is essential for what? High rise building, regular low rise building, all the structure, or none of the above. Here answer is high rise building. Okay, now question number 36, the zone factor for zone 4 as per IS 1893 is how much? It is 36. You see, that is 0.16. Now 37, what is the unit of seismic coefficient? This is dimensionless. Okay, now in IS 1893, the design seismic base year depends mainly on live load, dead load, seismic weight, or all of the above. Option C is the correct answer. Seismic weight. Design shear base depend only on seismic weight. Now question number 39. Sudden upliftment of sea floor can cause what? Tsunami, flood, cyclone, typhoon. Its answer is, tsunami. Okay. Now which soil is better against earthquake effect? Loose soil, hard soil, soft clay, or saturated sand? Option is hard rock. Okay. Now you see here, this is the answer key. You just click the photo, and if you want this PDF, please join my Telegram channel Civil Quick Revision. Now coming to another 20 question, I have combined this video. Okay, now in this question what they ask, you see, the base year VV is calculated by what? It is VB is equal to AH into W. This is horizontal constant, this is seismic weight. Option A is the correct answer. Okay, now coming to 2, the horizontal seismic coefficient AH is depend on what? Importance factor, zone factor only, seismic weight only, zone factor, importance factor, response reduction factor, or this is SA by Z. This is called spectrum acceleration coefficient. It is all depend on D. Okay, now coming to question number 3, the formula for horizontal seismic coefficient A is each given by which formula? You see, AH is equal to Z by 2, I by R, SA by Z. This is the correct one. Okay, you remember this formula. Now the time period T of a RC frame building is approximately how much? It is T is equal to 0.07 into 10 to H by 0 to the power 0.75. Now for steel frame buildings, the approximate formula for T is what? For steel frame, it is 0.085 into 10 to the into H to the power 0.75. Now seismic weight W is what? It's only dead load plus 25% live load, or it's a dead load plus full live load, or it is only live load. It is option B is the correct one, dead load plus 25% live load. Now coming to question number 7, lateral force at any floor Fi is proportional to how much? It is mass into height. You remember this. Now question number 8, formula for lateral force at any floor is given by how much? Formula for lateral force Fi is equal to Wi into Hi by summation of Wi into Hi into Vb. Then you see zone factor Z for seismic zones of 5 is 0.36. It is repeated question. It is a very important question. That's why it is repeating. Okay. Now coming to question number 10. Peak ground acceleration zone for zone 5 is approximately, this is same 0.36 G, same. Okay, in which layer, you see, in which layer of the earth do natural earthquake occur? Lithosphere, inner core, mesosphere, asthenosphere. It is the lithosphere. Okay, now coming to 12, which building shape is considered safest for earthquake resistance according to guideline? You see, L shape building, or it's a T shape building, or it's a H shape building. Sorry, it's like that, H shape building, or it's a square or rectangular type of building. It's a square and rectangular type of building because the symmetry are mainly in the centroid. Okay, that's why this is safe. Okay, now coming to 13, if you see, if K increases and M constant, the natural frequency is how much? It also increases. Now coming to 14, the base year formula W refers for what? This is seismic weight. Okay, is equal to dead load plus 20% of live load. Answer is B. Now question number 15, which parameter reduces seismic design forces as per 1893? It's a option, you see, importance factor, zone factor, response reduction factor, or dead load. It's a response reduction factor. Now coming to 16, unit of seismic weight AH is dimensionless. Some question are repeated. Okay, you just practice it. Question number 17, base year vary directly with what? It's a base square of height, seismic weight, response factor, plane area. It's a seismic weight. Now coming to 18, if a building has a double height, okay, double the height, approximate natural time period, how much? Increase, decrease, remain constant, or double? It is increases. Okay, now question number 19, as per IS 1893, percentage of live load considered for seismic weight in storage building is how much? We take the percentage of live load is 100%. Okay, in storage building we take all the weights of the material inside the storage building. Okay, because it is for safe, okay, for safety. Now question number 20, in the equation given here, AH is equal to Z by 2 I by R S by G, the factor I represent what? This I is importance factor, as we've already discussed. Okay, for this is for now today. Okay, I concluded here all the main importance topic of earthquake engineering. Okay, if you like my video, please share with your friends and subscribe my channel. And if you have any doubt regarding any topics related for PWD, JEE or upcoming exams, you please join my Telegram channel Civil Quick Revision, and you can ask any question. Okay, now today I conclude here. So hope you all like this. Thank you.